Dr. Barnes here. Let's look at this simple question in Fourier transforms. So first, you plot your graph of the signal that you were given. So this is the graph x of t. Okay, this is x of t and here is t. Okay, so what question are we given? We are given that x of t is equals to e exponent at into u of minus what? T. Okay, so whenever you see minus t is what? Time reversal. So this signal will always be what? 1. It will not touch it. It will be very close to it. Okay, so here is what? 0. Okay, so this is how you plot the signal. Now you just go ahead. Fourier transform x of w is equals to summation from minus what? Infinity to what? Infinity into x of what? T into what? E exponent j omega what? T. Here is minus. Alright? Can bring the t here. Okay, so now this is what we're going to have. So now we have x of w is equals to x of w is equals to integration infinity from minus what? Infinity. Okay, x of t is what? E a what? T into u minus what? T. Okay, into e minus j omega what? T dt. This is equals to what? If we look at our signal, okay, if we look at our signal, what we can see is that this place is supposed to be minus what? Infinity. So our signal is coming from minus infinity to 0. So now my limit here will change from what? Minus infinity to what? 0. Okay, and then e exponent what? 80. This u of minus t, I'll not bring it again because it's a unit step signal, which is what? 1. So I'll not bring it again. And then I'll add this one, minus j what? T. The what? The t. Okay, so now this is a signal I am going to what? Deal with. Okay, this is a signal I'm going to deal with. So I'll just integrate this signal straight away. Okay, so if I can also make this signal to be this way. Here, in this way, here is 0. So I can have what? E. Okay, E into what? E into a minus j omega. Okay, that can simplify it here. E into what? A minus j what? Omega into t. Okay, so here becomes what? Dt. So if I simplify this one, I'll get what? 1 over what? A minus j what? Omega into what? E. A minus what? J omega into what? T into what? Minus what? Infinity and what? 0. Okay, so this is what I am going to have in this particular signal. So now x omega is equals to 1 over a minus j omega. Okay, into what? Into e. Okay, into e into what? A minus j omega. Okay, t. Instead of t, I'll put the upper limit there, which is 0. Minus e into a minus j omega into what? T. Instead of t, I'll put what? Minus what? Infinity there. Okay. Alright, so that's what we get over there. Okay, so from there, what we can say is that x of what? Omega is now equals to what? Is now equals to 1 over a minus j omega into what? E exponent 0 is what? 1. Is 1. Okay, and then e exponent minus infinity is what? 0. So minus what? 0, which is equals to 1 over a minus what? J omega. Okay, so that will become our answer. Okay, so x of what? Omega, the Fourier transform okay, of x of t, okay, of x of t. So I can say that x of what? T, okay, here. Fourier what? Transform, okay. This one is what? 1 over what? A minus what? J omega, all right? And then I can also say that the modulus, okay, of the Fourier transform is going to be like this. 1 over root of what? A squared plus what? Omega squared. All right, so basically this is how you what? You get it, okay? So let us proceed from here by realizing our magnitude spectrum and then our phase spectrum, okay? So let's just proceed with that. Okay, so let's see our magnitude spectrum, okay? So our magnitude spectrum, okay, our magnitude spectrum, all right? So it's going to be magnitude spectrum, okay? So magnitude spectrum is x of what? Omega versus what? X of omega like this, okay, over with what? Omega. So now let's say that and then let's say that we are using the formula for the modulus, okay? So we are using this particular formula, okay, this formula. Okay, so now here what is going to happen is that if we assume omega to be what? 0, then if you put 0 here, you're going to have what? 1 over a squared. 1 over a squared is what? Going to be 1 over what? A. Root 1 over a squared is going to be what? 1 over a. Okay, let's say that omega is minus what? Infinity. If omega is minus infinity, and you put minus infinity squared is what? Is infinity. Root of 1 over root infinity is what? 0. If you have one item and infinity people are going to divide it, you get 0. So 1 over root infinity is what? 0. So let's say omega is what? Infinity. If omega is infinity, 1 divided by root of infinity is what? 0. Yeah, 1 divided by root of infinity squared is what? 0. Okay, because if you have one item and infinity people are going to divide it, everybody will get 0. Now from here, you just draw your spectrum, your magnitude spectrum, okay? So here we have omega here, and then here we have x of what? Omega, okay, into modulus, okay? So the highest one here is what? Here is what? 0. 0 is what? 0 corresponds to 1, 1 over a. So here is what? 1 over a. And then here is minus what? Infinity. And here is what? Infinity. So minus infinity is almost what? 0, 0. It's getting close to 0, but it will not actually be 0. One thing you have to note is that most of the time, the magnitude spectrum is always what? Even. Both for the what? The Fourier series and the what? Fourier transform. Consider this one is what? Even. And all the ones that we have so far drawn, they are what? Even. Alright? So now let's go to the phase spectrum. The phase spectrum. Okay. So this is the angle Z of what? Omega. Which is equals to tan inverse, okay, which is equals to the tan inverse of omega on what? A. Okay, so here x what? Of omega, and then let's say what? Omega, okay, versus, okay. So now here what I'm going to do is, let's say omega is what? 0. What is the inverse? What is the tan inverse of 0? If omega is 0, tan inverse of 0 is what? 0. If here is 0, here what? Also be what? 0. Let's say omega is minus infinity. If omega is minus infinity, tan inverse of minus infinity is what? Pi on 2. It's pi on 2. Okay. Let's say omega is what? Omega is infinity. What is the tan? Omega is what? Minus infinity. Tan inverse of minus infinity is what? Minus pi on 2. And then if omega is what? Infinity. What is the angle for tan inverse of what? Infinity is pi on 2. So from there, let's draw our this thing here. This one here is what? Omega. And here is what? And here is the angle, okay? X of what? Omega. Okay, right. So now here is what? 0, 0. Okay, here this place is what? Pi on 2. This place is minus what? Pi on 2. Okay, so let's say pi on 2 is going this way, and then minus pi on 2 is going this way. Okay, all right. So here, this place is minus what? Infinity. This place is what? Infinity. Okay, so minus pi on 2 and 0, 0 is here. Here is what? 0. So minus pi on 2 and minus infinity. That is somewhere here. And then pi on 2 infinity. Pi on 2 infinity is somewhere here. Okay, so they will not really touch the line, but they will be very close to them. Okay. So something of this word, sort. Okay, something of this word, sort. Okay. All right, so that becomes what? Our phase angle. And that will be the end of this question. Thank you so much.